When Newton was thinking about moving objects, he realized that objects in motion have a certain property which objects that are not moving don't have. Paul Hewitt calls that a property oomph. I'm not sure whether the term momentum was started by Newton himself, or whether it came to to use later on. But that's what Newton realized. Newton realized that moving objects have a certain oomph, certain what he called probably momentum, and the quantity of that oomph that they have, of the momentum, is equal to or depends on two things: how fast the moving objects are moving, and also on their mass. And the more mass an object has, moving at a certain velocity, the more oomph, the more momentum it is going to have. Another way to get a large momentum to an object, the object might be very, very tiny, very, very small, having a small mass. But if it's booking at a very, very large speed, it's going to also have a large momentum. And so we define momentum of objects as a quantity given by the product of their mass and their velocity. So that's what we call momentum, and in physics we usually use lowercase p for momentum. So momentum is equal to mass times velocity. Now, knowing this idea of momentum, we can now look at really how Newton started his mathematics in Newton's second law of motion. If you remember, here is the common way of writing Newton's second law of motion. The net force equals to the mass times the acceleration of the object. Now, when Newton thought about what is the net force, non-zero net force, doing to an object, what he really was thinking about is that he realized that a net force, non-zero net force, changes the oomph, changes this momentum of an object. And if you write the definition of acceleration in this equation right here, so instead of acceleration, if you write it as a change in velocity in time, you can start seeing the oomph coming into the equation in here. So the mass times the change in velocity, that's basically change in oomph. That's the change in momentum. So we can write the equation this way, and the net force is equal to, in the numerator there we have the change in momentum divided by time. In other words, we can write that the net force equals to the change in momentum, the speed of the change in momentum. So the larger the net force, the faster will be the change in momentum. And of course, the smaller the net force, the slower will be the change in momentum. But in other words, net force changes the momentum of objects.